Good morning, I'm Mrs. Boots, and we're going to look at logarithms and exponents. So you've never heard of a logarithm, but I know you know what exponents are because we just finished a whole unit on it. So we've got a few easy problems on the board there. So if you'll notice the first one, 2 squared. What is 2 squared? That's right, 4. And what is 2 cubed? So we multiply by 2 again, and you get 8. Very good. And then 2 to the 4th. Excellent, 16. Okay, so real easy. If I asked you 2 to what power gives me 8, you know that the exponent is 3. Okay, but what if I asked you 2 to what power is going to get me 12? So I know 2 times 6 gives me 12. But notice 12 is in between 8 and 16, so it's going to have to be a decimal. Can't just find it by working backwards. That's what logarithms do. Logarithms help us solve for this unknown exponent right here. I'm going to take my exponential form and turn it into a log. So if I have b raised to the power of x, we're just going to call it x because we're not really worried about what it is right now. And that's going to equal to a. A being an argument, not the answer, because the answer could change where the equal sign is, okay? So anything, so what we do is the first thing we write down is our base. So the base is always the big number that's attached to the exponent. When you write it in log form, the first thing you do is write the word log. I know we've gone from letters to words now. It's okay, we can handle this. So we're going to write our base, and we write it down and little. So our big base becomes little baby b. Okay, so the base always goes at the bottom. So in Microsoft Word, we call this a subscript, if you're familiar with that. So my base comes down. From the base, you go across the equal sign, so the argument is actually what you write next. The argument is inside the parentheses, and it's actually now part of my log. And then the last thing I'm going to write is the exponent. So notice when I turn my exponential into a log, the exponent is now by itself on one side of the equal sign. So we can go through and now solve, basically plug this into a calculator, because we don't have to memorize it nowadays. We don't have to use a slide rule or a table. We could plug this into the calculator and get this value, like 2.2 blah, 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 whatever it is. All right, so let's just look at how to convert. How do I convert from an exponential to a log and from a log back to an exponent? It's always easy, not a big deal. So if I'm starting with an exponent and I want to go to a log, the first thing I'm going to write is the word log. Okay? The very next thing we write will be the exponent. So we always start with the base. Whatever that base is, we put it down. Remember, it's going to be the little baby number at the bottom. We're going to put our parentheses with our equal sign. From the base, we go across the equal sign. The argument is what comes next. And then we come back, and the exponent is always by itself on the other side of the equation. And my exponent is 3. Okay? So now we've taken our exponential and turned it into a log. Think of it as like you're shuffling cups on a desk. You're just rearranging them. That's all we do. We just rearrange it. Okay, now we're going to do the same thing with the log. We're going to turn it into an exponent. So once again, we start with the base. The base is the little baby number. So I'm going to write my base down, only now it becomes really big. We go across the equal sign to find our exponent. So our exponent in this case is 2. And now that's equal to my argument. Now the argument could be in parentheses or it could be just by itself, but that's okay. The argument right here, 25. So 5 squared is 25. That means log base 5 of 25 is equal to 2. Right. So now let's look at this wonderful problem. We got all these different problems. Notice they're all dealing with 5s. Not a big deal. Okay, so for each one of these, for some people it's really hard to think in terms of log, but that's okay because we're going to rearrange it, turn it into an exponent so we can solve it. Okay, not a problem. So I start with my base. We would go across the equal sign, but there's no equal sign, so we're going to pretend. We're going to say it equals x. So I want to know what the x is. Okay, so I have 5, because that's my base. Notice it always goes counterclockwise. You start with the base, you go across the equal sign, come back. Every time. Doesn't matter if it's log or exponent. Start with the base, go across the equal sign, and then you come back. All right? So 5 to what power is going to give me a 5? Yes, it's a 1. X equals 1. Okay? So if I take 5 to the first power, I'm going to get 5. All right, so let's do the next one. Remember, you're pretending there's an x out there. You start with what? Very good. We start with the base. Go across the equal sign and come back. Okay? So 5 to the x power is going to equal to what? That's a 1. Well, 5 to the 1 power equals 5. Oh my. Okay, wait. Remember the exponent rules. Power of what always equals 1? Power of 0. Power of 0 always equals 1. Okay? So x is going to have to be 0 in order to get a 1. All right? So we're just going to keep going. Same thing. We got to start here. There's our log. What's our base? We're going to pretend there's an x out there. So I have 5 to the x equals 1/5. 5 to the x power. Okay, so again, got to go back to the exponent rules. I know 5 to the first power gives me 5, but how do I move it down to the denominator? What kind of exponent moves it to the other side? Negative. Very good. A negative exponent. Okay, so now x is going to be equal to -1 because the value of 5 didn't change. It stayed the same. It just moved from the top of the fraction to the bottom, from the numerator to the denominator. Okay, so now we have two that are very, very similar. You may think they look completely different. We're going to skip down to the last one, and then we'll do the middle two because it's easier, right? So 5 to what power gives me 125? So remember, we're going to pretend we got to put the x. We go counterclockwise, right? 5 to what power is 125? So 5. What power? Very good. It's the third power. So notice, if it's in the numerator and it gets bigger, it's a nice, pretty whole number. It's going to go higher, right? Could be the same. If it goes to the fraction, it's going to be negative. If it goes to 1, it's 0. So let's look at what happens when it gets smaller. This is a weird one. Okay? So we have equals x. So I start with the base, but the base is 25. That's okay, doesn't matter. I still start with the base, go across, and come back. Not a problem. So I have 25, because that's my base, to the x power equals 5. Oh, wow. What would I do to take 25 and get a 5? Yeah, we take the square root. Square root is equal to what exponent? You guys don't know. You're missing it. Okay? Square root is the exponent of 1/2. So if my number is getting smaller, but is not 1, my exponent is a fraction. Okay? It's getting smaller. The number is getting smaller. I go from the base to a smaller number. But my exponent, but I'm not going to a 1. It's just a smaller number. My exponent is going to be a fraction. Okay? So we just said a square root was the same thing as an exponent of 1/2. So this is equal to x. So we go 5. So the x power is square root of 5. Okay? So I have 5 to the x power is square root of 5. Well, square root of 5 is the same thing as 5 to what exponent? Yeah, 1/2. Okay, so I'm going to rewrite this as 5 to the 1/2. Well, that looks very, very similar to what we just did in solving exponentials in the last unit. Your bases are the same, so they cancel out. All right, which you could have done right here. We could have changed the base to 5 and then solved it from there. All right, so these are our simple mental math problems. Most of them will be like the first one and the last one where it's a nice, pretty whole number, but you may have some fractions and some negative numbers in there, so I want you guys to be aware of it.